Let us continue the discussion regarding the main features of long form of periodic table. We had discussed just now the various periods present in the modern periodic table. Now let us discuss about the various groups present in the modern periodic table. A vertical column in the periodic table is known as group, and there are 18 groups in the modern periodic table. According to the new recommendations of IUPAC, the groups are numbered from 1 to 18. Actually, there are two different methods of numbering the groups in the periodic table. The old one, it was based on the subgroups A and B. Means the groups from 1 to 7 were again divided into subgroup A and subgroup B. But now, according to the latest IUPAC system, all the groups were numbered directly from 1 to 18. And the elements with similar electronic configuration have similar properties, and hence they have been placed together in the same group. Means those elements which are having similar properties are kept in the same group, and that is possible because of their similar outer electronic configuration. This is the major point of discussion here. The order of various groups in the modern periodic table. Because in objective examination, always they will not give the options only according to the IUPAC system. They may also give in terms of the old system, dividing them into A and B. So this is the exact order from left to right. The first group, we call it as 1A, then comes 2A, then 3B, 4B, 5B, 6B, 7B, then 3 columns making 8th or 8B, then comes 1B, 2B, 3A, 4A, 5A, 6A, 7A and 0 group. Let us see directly on the periodic table. So these are the vertical columns 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 and 18. Now this is the numbering of the groups according to the IUPAC system. Now let us write the old system. So this is the 1A group, then comes 2A, and then comes 3B, this is 4B, 5B, 6B, 7B, and the column 8, 9 and 10 together made as 8th group or 8B. Then column number 11 is 1B, column number 12 is 2B. And then 13, this is 3A, means the continuation of 2A is here 3A. Then comes 4A, then 5A, then 6A, this is 7A, and the 18th group call it as 0 group. Let's continue the discussion. We are discussing about the groups in the periodic table. The first two groups on the extreme left hand side and the last 6 groups on the extreme right hand side involves the filling of s orbital as well as the p orbital respectively. Means in the first two groups of the periodic table, the electrons enter into the s orbital of a particular subshell, whereas in the last 6 groups of the periodic table, the electrons enter into the p orbital of a particular subshell. And these groups, means the first two as well as the last 6 of the periodic table, they represent the main groups of the periodic table. And they are numbered as, means the first two are numbered as 1 and 2, and the last 6 they are numbered from 13 to 18. Let us see directly from the periodic table itself. See here, I did not write the group numbers in advance because it is very compulsory to know the group numbers for you to answer the objectives. If you know the group numbers, then you can answer the question. It is 100% compulsory that you must be in a position to find out the group numbers easily for the elements. So that is the reason, to make you more practice, I did not write the group numbers on the periodic table earlier. I am writing in front of you. So this is again group 1, group 2, 3, 4, 5, 6, 7, 8, 9, 10 and so on. Now, according to the statement explained just earlier, the group number 1 as well as group number 2, the electrons enter into s orbitals, whereas in the case of group number 13 to 18, the electrons enter into p orbital. So that is the reason we call these two groups as the s block elements and these 6 groups as the p block elements. Anyhow, we shall discuss in next session separately regarding the classification of the elements into SPDF blocks. Then the elements present in the group 3 to 12, the electrons are filled in d orbital. Means this is group 3 and this is group 12. All the elements which are present in between group 3 and group 12, in all these cases, the electrons enter into the d orbitals of a particular energy level. So that is the reason why this entire, we call it as the d block elements. There are two more rows present at the bottom of the periodic table. These rows consist of 14 elements after lanthanum and 14 elements after actinum. So two separate rows are there below the periodic table. The first row starting from cerium, they are called as the lanthanoids, or we can call it as lanthanides. And the second row starting from thorium, we call them as actinoids or actinides. Let us see in the periodic table directly. Here, these elements from cerium to lutetium means from atomic number 58 to atomic number 71, they are called as the lanthanides. Actually, all the 14 elements coming after lanthanum, they possess similar chemical properties. As they cannot be accommodated in the same group, they are placed separately below the periodic table. Again, the 14 elements coming after actinum, atomic number 89, that is from atomic number 90 to atomic number 103. All these 14 elements, they are called as the actinides or actinoids. They are supposed to be placed at this particular point. So, as that space is not sufficient, they are accommodated separately below the periodic table. So that is the reason why these lanthanides and actinides, both of them belong to the same group, third group, and lanthanides belong to the 6th period and actinides belong to the 7th period. Let's move ahead to discuss about the advantages of the modern periodic table. The first one, the position of the elements in the periodic table is governed by their electronic configuration. Means, if we know the electronic configuration of the element, we can easily find out the position of the element in the periodic table. We'll understand better when we discuss the objectives at the end of the session. Second, this periodic table shows a gradation in physical and chemical properties of elements and their compounds in a group and in a period. As we know that in this modern periodic table, the elements are arranged in the increasing order of atomic number, and those elements which are having similar properties are kept in the same group. So there is a very regular variation in the properties of the elements. Third advantage, the division of the elements into S, P, D and F blocks has made the study more simple and has a logical explanation. Anyhow, that is the topic of discussion in the session 3. We will discuss it elaborately, and then I will explain a small part in this one. The division of elements into S, P, D and F block, I think you remember the major need of classification is to make the study more easy. So that helped the study more easy. Then the fourth one, based on the electronic configuration, the elements can be classified into inert gases, representative elements, transition elements and inner transition elements. And this is a topic of discussion in session 4. So we shall discuss separately there. The next one, the properties of new elements can be predicted even before their actual discovery. Because we already know the concept that those elements which are in a particular group, they possess similar properties. So if any extra element will be discovered in future, definitely we can predict their properties in advance. Now let us discuss about the drawbacks of the long form of the periodic table. Position of hydrogen. As mentioned earlier, hydrogen can be kept both in alkali metals as well as halogens. Hydrogen resemble both with alkali metals as well as halogens. So that is the reason it can be placed in both the groups, and still it's a controversial point. Hence it became the drawback. Position of helium. Actually helium, it is an S block element, but it is kept in P block elements along with the other noble gases. So that became the drawback of the modern periodic table. Then the position of the lanthanides and actinides. Actually, these lanthanides and actinides could not get any place in the main periodic table. They are kept outside separately below the main periodic table. and the designation of subgroups A and B has no significance, and that is the reason why the modern periodic table is now numbered from 1 to 18 from left to right according to the IUPAC system.